Okay, connection should be streaming. We're double broadcasting. It is February 8th. This is CS-030. Going to just YouTube broadcast. 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 Just Okay, it's February 10th, Wednesday. This is CS-030. I'm still arriving in game. Hopefully I got the broadcast set up before that all broke. Let me see if I'm arriving back. February 10th. Arriving February 10th. Arriving. All right, there's my audio. All right, hello everyone. I hope you're out there. The video should be set up. Let's see if we go into inception mode here. Let's see what's going on. Looks right. I'm streaming. Stream is coming through on YouTube and looking in game for it. Good morning. Let's see. An error occurred. Please try again later. Playback. All right, gotta fix that. All right, there we go. Inception has begun. Okay, so hello everyone. I'm in game now. The video behind me should be playing and I'm double broadcasting. Can I get a confirmation that we're double broadcasting? By chat, maybe. Double broadcast. Okay, switching to single broadcast. And single broadcast, we'll go single broadcast on YouTube. Single broadcasting on YouTube. All right. Hello, everyone. Good morning. February 10th. Welcome to class. Today we're talking about decisions. Let's bring up a calendar to see where we are. Let that pop out. Okay, February 10th. We have a chapter 4 technique due tonight. Chapter 4 is about primitive types. But today in class, we're talking about chapter 5. Friday there is an exam. A couple things I need to do today in order to get you ready for that exam is I need to get solutions to problem set 3 out for you. And when I do, I'll put them in game on the shelf on my back right. I also need to get you some practice questions. Those will show up on Canvas later today as well. I need to get those set up. Practice questions will be in the Milestone 1 section on Canvas. On Canvas, if you look under modules, there's a section called Milestone 1. Milestone 1 is where our placeholder is for exam 1, and that is where I'll put the review questions as 1 under Milestone 1 on Canvas under the modules. The solutions will be in game on the shelves behind me to my avatar's right. They're not, I don't have them out quite yet. Okay, today we're going to be talking about decisions, chapter 5, and we're going to start by looking at a slide deck. One request that I had from a student was whether or not I could make slides available online. And I have different practices for different classes, but in this particular class, I don't have PowerPoint slides. I'm presenting from web pages that I've, excuse me. I'm presenting from web pages that I've generated from the textbook. So all of the content that I'm presenting generally will be in the textbook. And if I do have supplemental slides, I'll make those available. To that end, today I do have some supplemental slides. So let's start with those. I'm going to get those up in a broadcast. All right. And I'm showing them in a window. I intend to be showing them in a window. I'm trying to find that window. Waiting for my computer to respond to my keyboard commands. There we go. Window has moved. Slides are set up. Good. All right. And let's get those slides rolling. Great. Position them so they look right. Great. All set. All right, here we go. All right, so now broadcasting on YouTube. Although I'm listening in game, if you have a question or you want to chat, I've got that up in front of me. We're going to be talking about decisions. And decisions are the way in which computers do things differently from one run to another run. If you want your computer to do something different, it has to make a decision based on some condition in the world, and then it will do something different. What makes computers powerful is their ability to execute many decisions very quickly, and their ability to chain multiple decisions together so that you get very complex behaviors from programs because they're able to evaluate many, many different conditions very, very quickly. Now, those conditions that it's evaluating are all based on some software engineer or some programmer's code that they've written. And so today what we're talking about is how does a software engineer or how does a programmer write code such that it makes decisions? And there's a structure to that, and that's the structure that we're looking at. All right. So the basic structure of a decision, I guess there are a few possible other ways you could imagine decisions happening in code, but the primary one is through if statements. So let's start by reviewing how if statements work. If statements allow you to control a choice about what lines of code the computer is going to run. For the purposes of this presentation, we're going to call those actions, and by actions I mean lines of code. The if statement is going to control which lines of code it runs based on a condition. And that condition is going to be another smaller bit of code. It's not an entire line of code. It's a small bit of code. And that bit of code must evaluate to true or false, meaning the compiler must be able to read that condition and turn it into a true or false value. And it can do that by calling methods. It can do that by evaluating relational operators, but it must end up being true or false. And based on whether it's true or false, an action will be run. So let's take a look at that. So first, let me set this up for you. We are looking at some code that's inside a class, but I'm not showing you the structure for the class. And I've just created a simple helper method here to try and abstract away some of the details about the system.out code. All this method does is when it is passed a string, it outputs it to the console. Doesn't return anything, so the return type is void. It's private, so it's just a helper method for this class, and it's static, meaning that it doesn't need an instance of the object in order to run, it just needs to be told to run by another static method or by some other user of the class. So a simple helper method. All right. Then we're going to create our main method. Standard main body here, main signature. It's public, it's static, it returns nothing. It takes as arguments an array of strings. We haven't really looked at the structure for an array yet in this class, but that's what that is. It's an array of strings. For those of you who are interested, that array of strings comes from the command line. So if you ever run a program from the command line, what gets passed into the args parameter is any words or text on the command line after the program is invoked. So that's how you can communicate with the program through the command line. Don't need to worry about that for now, though. What we do see is that we have a local variable declared. It's of type Boolean. That's a primitive type that we learned about from chapter 4, which means it uses 1 bit and it can have the value of true or false. It is going to be stored in a variable called condition. It's a name that we picked. And in the case of this code here, it's not initialized to anything. We're just declaring it so that the compiler knows how to reason with it when it's compiling later on in the code. You'll notice that I don't specify whether this variable is public or private. That's because this is a local variable. A variable that is inside the body of a method doesn't have a declaration of public or private because it's not ever used by anyone outside of this method. It's a variable that's declared and used within the body of the method, and then when the method is complete, that local variable goes away and it's garbage collected by the system. So that doesn't make sense to say public or private to a variable that's inside a method. It only makes sense to say public or private to a variable that's an instance variable. An instance variable is inside a class, but outside of a method. So in this case, if we had an instance variable, it would be probably declared above the sum method, but we don't. So this is a local variable called condition. So let's use it in the context of a particular if statement. Before we can use it, even though we've declared it, we must initialize it. I'm going to put a little box over it so we don't actually know what it's initialized to, because that'll help us think a little bit abstractly about the way in which our if statements work. So this variable is initialized to some unknown value when we start for the purposes of this code, but generally you might not know what it's set to because it could be brought in as a parameter. It could be the result of reading a sensor. It could be the result of making a network call. There are all kinds of reasons why at the time of writing your code, you may not know what the value of this conditional is. And so this box kind of simulates that. When we have a basic if statement, it looks like this. This is valid code, but I've structured it in such a way that it looks like a general kind of syntax for how you might write an if statement. A couple things to point out. The condition, as we've mentioned before, must be inside of set of parentheses. That's a Java-ism. You must have the parentheses around the condition. Within those outer set of parentheses, you can have nested parentheses as well, but you must have the outer parentheses. You can see that the if statement is over to the left of it, and you see that it is running, it's making a call to some method that's passing in the string literal a as the parameter. Now, when I introduced these slides, I said that there's a condition and there are actions. So to tie this back to the initial slide that I introduced, what I'm talking about with actions in that initial slide is the line of code right here, some method passing in the a string. That's the action that I'm referring to. And the condition is in fact the condition that's assigned, it is in fact the variable condition as well. So I'm both using it as a word and as a variable name. So as we look at this, syntactically, you must understand how this code runs, because in order to, first of all, in order to be able to write code, you must understand how the syntax works. And so the syntax here says that if condition, the variable condition, evaluates to true, then we're going to run the code that follows the if statement. By default, we run one line of code. And so this is going to output the letter, capital letter A, to the console by if condition is true. If condition is false, nothing happens. We fall through. So this is an example where something may or may not happen. Some method may or may not run in the body of this code because it depends on whether condition is true. But if condition is false, nothing happens because there's no alternative in this code. It's simply something that happens if something is true, a condition is true. Here's an example of when we would like our action to consist of multiple lines of code. So in this case, if condition is true, we will first call the helper method some method with the variable a, parameter a, and then we will return from that method and we'll make a second call to the same method, some method, and we will pass it the parameter b. And so the result of this, if condition is true, we will see a and b printed out to the console, each on its own line, because we're calling the println method, printline method in some method, which automatically puts a new line character at the end of each output. So a and b will be produced vertically on the console. Again, if condition is false, there's no alternative in this structure. It either runs what's in the actions or it doesn't run it. And that's all you got. Now you have to be careful because as we've talked about, indentation doesn't matter. And so what matters is reading carefully the syntax around your code. So in this case, no matter what, some method B is going to be called. It doesn't matter whether condition is true or false, some method B will always be called. And you look at that and you say, wait, I thought if statements only ran if the condition was true. That's accurate. The actions associated with an if statement only run if the condition is true. But what's happening here is that the actions that are associated with the if method are being presented kind of confusingly by the indentation method that's being chosen here. Without the curly brackets, the only action that's attached to the outcome of that if statement is one line. So some method A is the only line that's attached to the if statement. Some method B, although it has been indented, and quite frankly, I indented it in order to create a confusing situation, even though some method B is indented, it's going to be run no matter what. Because if condition is true, some method A will be run, and if condition is false, some method A will not be run. But regardless of whether condition was true or false, the if statement will continue afterwards and run some method B. If this is confusing, consider the difference between the second example with curly brackets and the final example without curly brackets. The final one will always run one line of code. The middle one will not necessarily run any lines of code except for the conditional. All right, I'm going to switch now to a different structure of the if statement. Are there any questions about this structure of the if statement before we move on? Okay, provided the lag has not impacted your ability to respond to that. Before we move on, let me have you in chat output what this main method will actually output should the condition be revealed as follows. What is actually going to happen in this code? And go ahead and use chat to output what you think the answer is going to be. And as you're working on that, let me remind you that being able to understand someone else's code is the first step for being able to write your own code. Because at some point, you're going to want to use if statements to create an effect. And unless you can understand how effects are created, you're not going to be able to effectively write your own if statements. So what do you got? I don't see anything in chat yet. Okay, there you go. Got one answer. Okay. We have a little dissension on what the right answer might be. One thing that we're not able to do in this chat very effectively is to put new line characters in. And so we have to be a little bit careful about that because we're typing in letters, but we're not able to do new lines without sort of destroying the chat. Okay, a lot of different answers here. Let's walk through what is happening. All right, so for starters, let's evaluate whether condition ends up being true or false. So that code there, that parentheses 3 less than 4. That is a relational operator. It is an operator just like a plus or a minus or a times, only instead of giving us an integer as a result, it gives us a Boolean as a result. And so when we evaluate 3 less than 4, that's either going to be true or false. 3 is a literal, 4 is a literal, so it can get evaluated without even running, without even executing the program. The compiler can figure it out just from the source code. The answer is true. 3 is less than 4. So therefore, condition as a Boolean will take on the value of true, and in each of the 3 if statements below, condition will evaluate to true because it is a variable whose value is true. And it means that in each of those if statements, we're going to run the lines of code that are associated with the true case in that code. So as we look at that first one, if condition some method A. So that means we are going to output the first A to the command line. So I'll type this into the chat. Although I can't reveal it till I hit enter. So the first thing we're going to print is we're going to print A, and then we're going to have a new line character after it. So I'll just go ahead and print that as a string. You'll see in a second. We get to the second if statement. Condition hasn't changed. It is a variable, so it's possible it could have changed if some code had changed it beforehand, but it hasn't. So condition is still true. So we're going to run both of those lines of code in the curly brackets. And so we're going to print out an A followed by a new line, and then a B followed by a new line. And then we get to the third conditional. Condition is still true. And so as a result of the condition being true, we're going to run some method A. And so we are going to output A and then a new line character. Now, after we execute that third if statement, there's one more line of code to run, which is some method B. And some method B is also going to get run as well, even though it's not guarded by any kind of if statement. Some method B gets run in this code no matter what condition is set to. So as I read my result, let me see if I can clean this up so it looks consistent. All right, so I get this is how I'm outputting my result. And so what you see there is the string A with the new line characters output, A with the new line characters output, B, new line, A, new line, B, new line. So I think shorthand, if you had A, B, A, B, then that would be an adequate answer. Questions about that? Not everyone nailed it, so just make sure you understand what it is if you didn't quite follow. All right, rolling on unless someone speaks up after lag. Okay, so now let's introduce the if-else statement. The if-else statement also controls a choice, but it's going to control a choice between two actions based on one condition. So again, the condition must evaluate to true or false, and the action can be one or more lines of code, but there are two outcomes in an if-else statement. Let's hope I got my code right here. All right, so let's take a look at this. A similar structure here. We have a main method within a class. We have a Boolean conditional. It's a local variable, and so there's no need to have it be indicated as public or private. We initialize condition to some value, which isn't revealed yet. And we have our first case here. In this case, we have an if, and then we have an else that is bound to that if statement. And in this case, because of the if-else structure, only A or B will be output. One of them definitely will be output. Both of them will never be output. That's because the condition must evaluate to true or false. It's either true or false. It's as binary as you get. And so if it's true, we'll run the first line, and if it's not true, we'll run the second line. So something is going to get run here. We don't know what because we don't know whether condition is true or false. And that's something powerful we can use for programming as a result. Now notice, again, there are no curly brackets here. And as a result, only one line of code gets attached to both the if statement and one line of code gets attached to the else statement. If we want more than one lines of code attached to the preceding if or the preceding else, then we better encapsulate it in a set of curly brackets, regardless of what the indentation is. So here's an example of that, kind of. You can see we have the if statement. We have some actions associated with the true condition, true case, if condition is true, and we have some actions associated with the false case. Again, you have to be very careful of scoping here. The indentation suggests that you're either going to have A and B output or you're going to have C and D output. but the indentation is deceptive because in fact, the else statement only has one line of code attached to it, which is that sum method C line of code. And so the two outcomes for that conditional statement are either A and B are output or C is output. And then regardless of what condition is, D will be output no matter what. Because although D is indented, it is not attached to the else statement because it is not enclosed within curly brackets, nor is it the line immediately following else. Probably what the programmer intended from this line of code was to do something that looks more like this, where you encapsulate both the A and B and the C and D line within curly brackets, scoping the actions that are attached to the true case and the false case kind of appropriately. So in this case, you have either A and B are going to be output or C and D are going to be output. You'll never have A output without B. You'll never have C output without D. You'll never have A output at the same time that C is output. And you'll never have B output at the same time D is output. They have been made atomic. Each one of those conditions is wrapped in curly brackets, so you get one or the other. Okay, any questions about the way the curly brackets and the else statement work together? Any questions about that structure? Okay, let's do another check then. If we reveal a condition, what's actually going to be output? Go ahead and type in chat, see how you do. Okay, looks like a few of you are still typing. There they are, they're all flowing in. Ethan for the win with the Professor Patterson OCD \ns. Ben, props for the same thing. Okay, great. So as I look at this code, one thing that should have been clear is at one point when I was explaining this, I said that the first example of sum method D is going to be run no matter what. So if your answer doesn't have D in it somewhere, then it's clearly not going to be correct because that sum method D is going to be run no matter what. So let's start at the top. 3 less than 4, that evaluates to true. And so we can just, from that point on in the code, just understand that condition is true. So as we go through each one of those if statements, condition is never changed in between any of them. And so condition remains true throughout the whole code, the rest of the code. So as we get to that first if else block, we see that there's 2 lines of code, 1 line for each attached to if, 1 line to else. So that first line of code is going to give us an A output. So let me type that out. The second if else block, condition is true. So we're going to see the A and the B output. Let me put that in chat. A and B. Okay. Then we have to look at how the rest of the code plays out. We see that else does not get run, but sum method D does get run because that is outside the scope of the else block. So D gets run. Then we get to our third conditional. Condition is still true. The variable condition is still true. We see that both the if statement and the else statement have code enclosed within the curly bracket. So we're going to run the first set of actions and we'll get another A and another B as a result. B backslash n. Okay, and so the result to me looks like A, B, D, A, B. A, B, D, A, B. Does that match? Does that seem to match what your understanding of the code is? Is there anything about that that's not clear? Did I get it right? Okay, let's look at the third primary structure for doing decisions then. The third primary structure is if and else if statements. Now, one thing that I like about the way that Java does this is that Java doesn't create a separate reserved word for the else if statement. It just kind of chains them together. And so what the if else if statements allow us to do is it allows us to control a choice that chooses between several actions based on several conditions. And so each condition along the way, and we're going to have several of them, must individually evaluate to true or false. And again, actions are going to be lines of code that are associated with each one of those conditional evaluations. So let's take a look at what that looks like. Similar structure as before. What's a little bit different here is that I've introduced 3 Boolean variables. Now, notice that when I created those local variables, condition 1, condition 2, and condition 3, I used a kind of shorthand in order to declare all 3 of them. I have the type on the left, and then the variable names are on the right with commas between them, and then a semicolon at the end. That's just a shorthand way of declaring all 3 variables on one line. I could have declared them each individually on 3 separate lines if I had written Boolean conditional 1 semicolon, Boolean conditional 2 semicolon, Boolean conditional 3 semicolon. There's not a better or a worse way to do it. It's just whatever seems to read easier or make more sense in the context of your code. My declaration of those 3 variables is not sufficient to be able to use them, however, because they have to be initialized with some value in order to be able to use them. And so this first block here is blocking what value they are being initialized with. All right, so let's look at our first structure here. In this example, we have an if-else-if block. Only one letter is going to be output, A, B, C, or D. Only one of those is going to be output, and for sure, one of them will be output. How do we know that? Well, we know that because conditional 1, by virtue of being a Boolean, is either true or false. If it's false, then we go to our else if statement and we consider condition 2. If condition 2 is true, then we're going to run some method B, and 2 is either going to be true or false. If we get to the second else if line, the third if statement, else if, we know something about the world at this point. We know that condition 1 is false, and we also know that condition 2 is false. Because if condition 1 and condition 2 hadn't both been false, we wouldn't have been able to get to the test on condition 3. So by the time we get to condition 3, we're evaluating whether condition 3 is true or false. It's either true or it's false. If it's true, we will run C, and if it's false, we will run D. And so because we know those 3 conditions can only take on true or false, and because we have an output for we have an action for every single option, we know that A, B, C, or D will be run, and only one of them will be run. Because, for example, if condition 1 is true, we will run some method A and then jump all the rest of the else statements. We'll leave that entire if-else-if block. If condition 1 is false, and we go to the else if condition 2 block, and condition 2 is true, we will run some method B, and then we will leave because we don't want to follow any of the other else's because condition 2 is true. So we think of this as a linear sequence of tests, which is treated all together as one structure, so that if any of our tests end up being true, we leave our final else block. So only one letter is going to get output, A, B, C, or D. And the thing to notice here is that this structure, in addition to giving us several possible outcomes, actually causes the conditions to interact. The conditions are interacting indirectly because if condition 1 is true, we're never going to evaluate condition 3. So there's a kind of like a hierarchy or a priority that's built into this if statement, this if-else statement, such that condition 1 is considered the most important condition. And if condition 1 is true, then we don't care about condition 2 or condition 3. We don't even evaluate them. And condition 2 is less important than condition 1, but it's more important than condition 3. So if condition 1 is false, then we consider condition 2. And if condition 2 is true, we don't even care about condition 3. And finally, condition 3 is the low man on the totem pole. To use a horrible metaphor, both sexist and appropriating indigenous culture. All right, so I apologize for that. Condition 3 is the weak dog in the pack. Let's use that as an example. Wow. Um, so if condition 3 is only evaluated if condition 1 and condition 2 are false, and then we'll evaluate C or D. All right, now you have to be careful about this structure because notice that we have else ifs in the middle and we end finally with an else block. That final else block is not required. Just like in an if statement does not require an else. We saw that in the first example. If statement can be there by itself. Similarly, because this structure is just adding another if statement to the end of a chain, that last if statement doesn't need an else either. And so we could also see our structure be something like this. We could see an else if statement, we could see an if statement, an else if statement, and an else if statement at the end. But you can see that if condition 1 is evaluated false and condition 2 is evaluated false, so that we get to the final example, and we finally get to condition 3, and condition 3 is false, then there's no alternative. So in this particular block of code, it's possible that we could evaluate this block of code and nothing would actually be output. Because if condition 1 is false and condition 2 is false and condition 3 is false, there's no work to be done. There's no final else statement to catch the default. In the top block of code, there is a final else statement to catch the condition if all 3 are false. So you have to be careful about this structure. And you can also see here that what I've done is in the second block where I say else if condition 2, I've put 2 lines of code there. I put them inside curly brackets. So there's actually 2 things that happen if condition 2 is true and condition 1 is false, such that we get there. If I had under if condition 1 in the second block where it says sum method A right there, if I had put another line of code after that, for example, I had done sum method A and then sum method B immediately after that, and I hadn't put it in curly brackets, Eclipse would have actually generated an error for me there. It wouldn't have allowed me to write that code because the syntax is broken. I would have to put it within curly brackets in this particular case because there's no other way to interpret this code if there's more than one line but not curly brackets. Okay, questions about this structure? Any questions about this structure? I guess I kind of have to wait for the YouTube to play out, otherwise you don't know what I'm asking questions about. Okay. All right, you know it's coming. Okay, if this is your code and conditions get run as follows, what is actually going to be output? That was a distractor. Okay, seems like there's good thinking going on based on just evaluating the typing and the amount of time it's taking you to process this. So the first thing to understand as we try and evaluate what the correct answer is, props to Luke for giving me the full OCD explanation, Ben as well. The first thing to do is to think about how are these conditions being evaluated, all right? As I put in the note there, it's not necessary to actually use variables to capture these conditions. We could do what we call inlining these expressions directly, meaning that instead of saying if condition 1, we could in the first if statement say if math.pi is less than 4. we can put that evaluation, that relational operation, directly where condition 1 is in the if statement. We don't have to introduce variables, but I was doing that just for the purposes of trying to understand, trying to explain the structure a little bit more clearly. All right, so what's actually output? What we need to do in order to evaluate this code is we need to understand how condition 1, condition 2, and condition 3 get evaluated. Condition 1 is asking if a particular constant is less than 4. What we're doing here is we're using a static constant. So it's static because we're using the name of the class, math, which is part of the Java language by default. We're using a capital M, which means we're looking at the recipe for the class. We're not actually instantiating it with a constructor. We're looking directly at the recipe. Math has declared within it a static public constant called pi, which is a double, which is a way of representing the approximation to as close of an approximation to pi as we can represent within a floating point number. We know that pi is roughly 3.14, and so that's less than 4. So math.pi less than 4 as a relational operator is comparing two different floating point numbers, and it is true. Condition 1 ends up being true. Condition 2 uses the negate operator. So the exclamation mark, sometimes shorthanded as when speaking as bang, bang condition 1 or exclamation point condition 1 is the negation of whatever condition 1 is. So condition 2 ends up being false because condition 1 is true. And finally, in condition 3, we again use a static constant e, which is approximately 2.7. It's another mathematical constant that we find in the process of doing math. It is a static constant. We're accessing it through the name of the class, which is capital M math. That capital letter is how you know you're accessing the static member. It is not greater than 4, and so condition 3 is false. So we have true, false, false for the state of our three variables. Now we can go down to our code and we can execute the logic of these if statements. We see that if condition 1, then we're going to output A. Well, condition 1 is true, and so we're going to output A. By virtue of the way this code is structured, the way this if-else block works, we therefore don't consider any more statements within this block. We leave the final else block and we continue down to the second if-else block. In the second if-else block, condition is still true, and so we're going to output A again. We have executed a true outcome for one of our relational operators within this if block, and as a result, because we have evaluated to true, we won't evaluate anymore. We'll go down to the bottom of this chunk of if-else statements. There's no more code to run after the final else if, and so we leave. And so the answer is with AA. That's correct. Let me just make that clear in the text as I was being smart aleck and putting fake answers up because that's how I am. Correct answer would be A and A on two different lines of code. All right. Any questions about these three primary ways of structuring logic in Java? The if statement with no else, the if statement with an else, and the if statement with a sequence of else ifs and optionally a final else. Three different logical structures for setting up if statements in Java. Okay, let's do a little bit more. Oh wait, I got a question coming in. So excited. Question, so excited. Oop, accidentally just faded to black on the YouTube. That was a mistake. Go back to my slides. Okay, just typing. Maybe not a question coming in. You can unmute too if you need to ask a question. Okay, moving forward. Okay, let's do a little backup. Let's review the difference between these three different options. Let me give you a chance to look at them for a second. If you have a piece of paper next to you, try and jot down what you think the difference is between these four examples of equal statements. And while you're looking at that, Morgan asks, is there a specific time when you would only use the if statements? And the answer to that is you should really think of these as tools. And yeah, there's a specific time when you would use it, whenever you need the effect. So they are tools that you have available to you to structure code. And so before you can choose which tool is appropriate, you have to understand what it is you're trying to achieve. And it's hard to just talk about abstractly when you just want the if statement. But like, um, maybe you're trying to figure out what you want the salutation on a letter to be, and you're trying to choose between um, Mr. or Ms., and you have a variable that's equivalent to gender. All right, so you have a string variable that is um, perhaps F or M or perhaps an empty string. So you've got three choices, and you have an if statement that evaluates those three strings. And if it's an M, then you're going to do a Mr. And if it's an F, then you'll do Ms. And if it's an empty string, then you'll put nothing at the front of the name. All right, so that's an example where you could think about one of those three structures that would be appropriate in order to evaluate the situation that you have there. You don't ever want to have Mr. and Ms. output at the same time, and having nothing is a fall through case. And so there's a couple different ways in which you could structure that as a result. And in fact, that's kind of interesting. Why don't we go ahead and take a look at that? That's complicated enough that maybe I actually need to explain what would be a good outcome, notwithstanding the fact that we're wading into dangerous waters with gender, but that's okay. All right, let's see. Class for today. Here we go. Let me make a new. All right, so I should be broadcasting on screen code. That looks good. Let me make a main method. Go ahead and finish that. I'm looking at code. Let me make it a little bit bigger so you can see it. Good. All right, so here's the main method. Let's make a private append salutation, and what we will get is we will get a string which is the name, and we will get a string which is gender. All right, and here the way we would call this is we would say, okay, I would like to say that my final greeting equals append salutation to Patterson and male. And maybe I would be getting these from a database instead of literals here, but for the time being, we'll just do this. This is private, and it's going to return a new string. And so what I want to do is I want to make a decision based on the gender. All right, so first thing I could do, there are a lot of different ways that you could structure this. You could do an if, you can do returns in order to end the consideration as well. Let's do if statements, and let's do it without any premature return. So let's first check if gender equals the empty string. That's one thing we could do, or we could say if gender dot length equals 0. Let's do it that way. They're kind of equivalent. We could do different things. Then we are going to, let's say, our string, our answer. We're going to initialize our answer with, we'll just say string answer, and then we'll start that answer equals name. So by default, our answer is just going to be the name that was passed in. And then at the end of our code, we're going to return our answer, and we're going to do the work in between. If gender.length 0 equals 0, then we don't want to do anything because we've already got it. So let's go ahead and put that in there to make it kind of clear. All right, so we could also then put an else statement here and say if gender.equals f. Let's make it a little bit more robust rather than just saying f. Let's say if gender.lowercase starts with an f. All right, so that makes our code a little bit more robust. It says if whatever's passed in as gender, we're going to convert the whole string to lowercase, and we're going to ask if it starts with the letter F. So that'll capture a capital F, a lowercase f, female, capital F, female, lowercase f. Only, I guess it's going to catch like furry too, but that's okay. All All right, so if that's the case, then we want answer to equal Ms. with a space plus, oops, plus name. Okay. And then finally, we'll put an else statement at the end that's going to capture absolutely everything else. We're going to capture, regardless of whether it is an M or an F, as long as it's not 0 and it's not an F, we're going to assume it's Mr. And you have to think about these things because you put a bunch of bias into your code when you do stuff like this. So yeah, let's not assume it's going to be a Mr. if it's not anything else. Let's formally check that. Okay, so as not to introduce a bias that everyone is assumed to be male if the code isn't F, we're going to explicitly say same thing with an M, and then we'll say name. And again, this is going to catch anything that starts with an M, like if it's like, I don't know, monster, it'll be M2, or if it's Mulligan or Mulberry or Mulholland, it'll all be Mr. So then we need to say, okay, well, what do we want to do if a gender has been passed in, but we don't recognize it, and it doesn't start with F or M? And I don't know what's an appropriate thing to do, but we do want it to be something because we need some final case, because if we don't put a final case in here, then answer doesn't get assigned anything. So I don't know, let's be inclusive and just say answer equals, I think MX is like, isn't that like a super inclusive way of doing a presentation? That's a little, I don't know. I don't want to get into the whole politics of it, but that's just an example. We're going to get something out as a result. All right. So we come back here and we say, all right, what went wrong? Why is Eclipse saying there's a problem here? Saying cannot make a static reference to a non-static method. Okay, so I can't call append salutation because it's not a static method. It is a method that can only be called if we decide to create a decision3 class. But we don't need that, so I'm just going to make it static, and then it'll run. All right, so let's output. Okay, and how'd we do? We're getting a complaint, and it's because I've got too many E's in there. Great. All right, so run this. Let's run it with code coverage as a Java application. You can see that the result is Mr. Patterson. Okay, so that's pretty good. That's what I hope to have happen there. And you can see that when I ran this, I ran final greeting and I called append salutation. I went into append salutation. This first line of code was touched because it's yellow. This line of code did not get run because gender.length was longer than 0. The second else statement got touched, it's yellow, but this did not get run because it does not start with F. This third line of code got touched and it did get run, and so my answer was Mr. And then you can see this final else statement did not get run because I had already achieved a true case in my else block. Finally, after all these were run, I returned answer as a result. If I change this and I make my gender lowercase female, and I do the same code coverage work, I see that the result is Ms. Patterson, and you can see that how this passed through was a little bit different. My if statement was touched, that's why it's yellow, but this was not run, that's why it's red. My else statement was touched, and then this was run because it was F. Because line 12 was true, no other if statements got touched. This one did not get touched because I already had a true condition, and my else statement did not get run. Finally, if I say I am a cute dog. Hey, by the way, I think I found out what kind of dog Dodger is yesterday. It's called a Basinga. Basinga. It's like an African dog, and I think he's mixed with a Rhodesian Ridgeback. Ridgeback. Did I get that? Basinga. I think I spelled that wrong. Something like that. It was very cool. We read the description on the American Kennel Society website and we're like, oh, that's totally Dodger. But he's not a purebred and also not Ridgeback. All right, so if that's, I guess, my gender, it's more of a species. We'll coverage that. See what happens. I get the result is MX Patterson. All right, and you can see how that worked out. I touched the first line did not run it. I touched the second line, did not run it. Touched the third if, did not run it. Got in my else condition, did run it, created my answer, and then returned it, giving me the result that I have there. All right, so the reason why I was showing you that was to answer Morgan's question about, is there a time when you use one or the other? And hopefully through my talking through the particular example here, you see that the process of choosing what kind of if statement can't really be done apart from the structure of your code and the result that you want at the end of it. And then, of course, we got into this situation where just this simple kind of situation is putting a bunch of bias into our code and forcing us to make a bunch of decisions about how we're going to represent gender in our code. One of the things that the current popular discussion about gender, in particular being driven by LGBTQ community and the transgender individuals, one thing that's sort of amazing to me about that is regardless of how you feel about all of those discussions, I think it has made it clear that there are a lot of times when we are asked for gender within these computational systems and databases that we're reviewing, different programs that we're a part of. And it's really caused me to ask, why do you need my gender right now? Like, gender should not be relevant at all to my Starbucks points card. It shouldn't be relevant at all to whether or not my Uber account works. It shouldn't be relevant to all kinds of stuff, and we're still asked for our gender. And so, like, I value what the LGBTQ community has done in this discussion by asking us to consider whether or not that's even a just or appropriate question to be asking in a lot of the computational systems that we've built. I think there are very few places where we actually need that flag. Probably just in health situations, and possibly situations where privacy of various kinds is designed. So you think you're just doing software, and then you find yourself in the middle of all the cultural problems questions that we have. Okay, back to our slides. Morgan, did that help answer your question? Sorry, get all my issues. All right, so as I look at what's on the board now, we're asking what is the difference between these particular situations? Okay, great, Morgan, thanks. The first example is an example of an assignment statement. And this assignment statement is taking the value of box 2 and duplicating it in box 1. So it's an assignment statement. The equals is not operating in any kind of conditional way at all. The second example is a conditional equal. So this second line, box 1 double equal box 2, is a statement that will evaluate to either true or false. And so it can be put in a conditional for an if statement or any other place where a conditional is appropriate. It will check whether two things are equal. And so if they're two references, if they're references to objects, it's going to be asking whether or not it is the exact same object. It's going to be asking whether these two variables reference the same spot in memory exactly. The third example doesn't have any translation in Java. So triple equals, it makes sense in JavaScript, but in Java, a completely different language, by the way, JavaScript and Java only have the first 4 letters in common. The languages themselves are completely separate languages. It is an unfortunate byproduct of history that they have similar names, but the Java language and the JavaScript language are completely different. The triple equals does not apply to the language that we are learning. Finally, the fourth line, box1 dot equals box2, this is simply a method that is part of the methods that are provided by box1's type. It takes as a parameter another variable, and we'll assume it's the same type, and typically the way this is used is to evaluate whether the instance variables within box1 and box2 are set to the same value. So in this way, you can evaluate whether two rectangles are the same size, but maybe aren't represented by the same chunk of memory. Box 1 and box 2 evaluate strictly whether two things are the same chunk of memory. Box 1 dot equals box 2 evaluates whether they should be considered equivalent or not. As someone who writes the code for a class, you are responsible for implementing the equals method, the dot equals method. And therefore, you are responsible for deciding whether two objects should be considered equivalent based on their instance variables. And how you do that, just like the if statement, depends on your design and what kind of outcomes you want as a result. Okay, charging ahead forward boldly. What is null? So here's an option of something that we could do. We could say box equals null. Null is considered a particular spot in memory, and it is a way of initializing a reference without having to call a constructor. Now, it is a little bit like setting a variable equal to 0, or it's a little bit like setting a string equal to an empty string, except that null is used for object references. And it is a way of giving an object reference a value, but it is not enough that you can call a method on it. Let's see if we can take a quick look at what this would look like in the context of Eclipse. So switching over to code, rolling over real quick. Let's make a quick example. All right, so I've got my main method, and let's use the built-in rectangle class, not the one that we created, but the one that comes with the Java language. Or let's go ahead and do our shortcut and ask for Eclipse to import the right class for us. So now we just have a warning that is because box is not being used. If I did want to say box, like if I wanted to say system.out.println and say that the parameters of the box are width, let's see, let's just not belabor this too much. All right, we can do that, and what we expect is we expect that that's going to output 0 because rectangles, when you do nothing in their constructor, have a 0 width and 0 height. Let's make sure that's correct. That's correct. All right, now if we wanted to, we could create another rectangle box 2, and we could do this, and we cannot use it because there is no initialization. So Eclipse will recognize and say, hey, you never initialized that, and so you can't actually use it. We can initialize it to null, and now we can actually use it. Eclipse is only going to give us a warning now and tell us that, hey, box 2 never got anything other than null. It can only be null. Because if we actually get to this code right now, it's going to crash because a null reference, you can't call a method on a null reference because you haven't actually initialized it yet. So it is a way of initializing a reference, but it isn't a way of getting around problems. Because if we run this code, it's going to crash because we try and call the method on a instance that we've never initialized. So if we run this now, you'll see we get a nice little crash. Can't wait for it, wait for it, crash. Okay. Right, and we could, if we fix that up and we run it again, then it will not crash. There we go. Okay. All right. I think what we're going to do, let's see, the next class is an exam. And so what we'll do at the start of Monday's class is we're going to work through a couple examples, and I'm going to ask you to work together in groups in game. And so in order to do that, you're going to have to make sure that you have your mic available and make sure that you're able to interact in the world okay. And you'll work together on an assignment in game. And so just be prepared for that on Monday. I was going to have you do an exercise today for the purposes of attendance, but I just wasn't able to get it together in time with trying to get it to work with all of the tools. So what I'm doing right now is I'm screenshotting who's present in class in order to take attendance. Just got it. Let me just read off names real quick. You don't have to respond, but if I don't call your name, let me know because there's something wrong and you're not going to get credit for attendance. So Adeline, Ben A, Ben F, Ben D, Ben, Carson, Ethan B, Ethan V, Ethan, Faith, Frank, Josh, Landon, Luke, Matthew, Dee Morgan, sorry, Luke being Monty, Matthew, Dee Morgan, Thomas, and Trent. So without further ado, thank you for your attention today. I'll stick around to see if you have any questions. Otherwise, you are dismissed. Okay, that's wrapping up February 10th, Wednesday's class. We'll go out on some music as I go back to my desk, my in-game desk. Music by Soft and Furious called Morph. All right. Thanks, everyone. See you next class.